NFPA 90a 7.2 mandates radiation dampers be tested firstly after installation to ensure proper operation before putting the system into service, and secondly every 4 years to verify continued functionality and compliance. Broan RDH exhaust fans have radiation dampers, but the manufacturer does not provide a written test procedure for them. This raises a compliance issue because NFPA 90a requires testing. There are possible solutions. Firstly, obtain a test procedure from a third party. Contact an independent testing agency or fire protection engineer to develop a test procedure for Broan RDH radiation dampers. This would involve testing a sample of dampers to determine a reliable and safe method for activation. Secondly, contact the local authority having jurisdiction, ODJ. Reach out to your local fire marshal or building inspector to discuss the situation. They may be able to provide guidance or grant an exception if they deem the radiation dampers to be adequately reliable without testing. Thirdly, re-evaluate the need for dampers. If the dampers are not legally required in the jurisdiction, consider removing or deactivating them. This would eliminate the need for testing. Recommendations include: firstly, prioritize safety. Ensure that the radiation dampers are installed and maintained in a way that protects building occupants from fire hazards. Secondly, document attempts at compliance. Keep a record of your efforts to obtain a test procedure or resolve the issue with the AHA. This documentation will help demonstrate due diligence. Thirdly, collaborate with the manufacturer. Continue engaging with Broan to gather more information or explore possible testing options. Additional considerations are: the fusible link activation temperature may vary from 100 to 65 degrees Fahrenheit depending on the model or installation conditions. Testing may involve using a heat gun or other controlled heat source to activate the fusible link and observe the damper's response. Ensure the testing is performed by qualified personnel and in accordance with any local codes or regulations. The radiation damper testing requirements outlined in NFPA 90.1-7.2 are crucial for ensuring the safety and integrity of fire protection systems in buildings. Understanding these requirements and exploring potential solutions when encountering challenges, such as the absence of a manufacturer-provided test procedure, is essential for compliance and maintaining a safe environment. Independent testing agencies and fire protection engineers possess the expertise to develop reliable and safe test procedures tailored to specific damper models. Their involvement ensures that the testing methodology accurately assesses the damper's functionality in compliance with safety standards. Consulting with the local AHA, such as the fire marshal or building inspector, can provide valuable guidance and insights into local regulations and interpretations of NFPA 90.1. They may offer alternative solutions or grant exceptions based on specific circumstances, ensuring that the overall fire safety objectives are met. Removing or deactivating dampers should only be considered if they are not legally required in the jurisdiction. It is crucial to thoroughly research and understand local building codes and regulations before taking such action. Prioritizing safety in all aspects of radiation damper installation and maintenance is paramount. Ensuring that dampers are properly installed, regularly inspected, and maintained according to manufacturer specifications contributes to the overall fire safety of the building. Documenting all efforts to obtain a test procedure, resolve issues with the AHA, and comply with NFPA 90.1 demonstrates due diligence and can be valuable in case of inspections or legal inquiries. Maintaining open communication and collaboration with the manufacturer is essential for gathering information, exploring testing options, and addressing any concerns regarding the damper's functionality or compliance. The fusible link activation temperature is a critical factor in the damper's operation. It is essential to verify the correct activation temperature for the specific damper model and installation conditions to ensure proper functionality in the event of a fire. When conducting testing, it is crucial to use appropriate equipment such as a heat gun or controlled heat source and follow a safe and reliable testing methodology. Observing the damper's response to heat activation provides valuable information about its functionality and compliance. All testing activities should be performed by qualified personnel who are trained and knowledgeable in fire safety procedures and regulations. Adhering to local codes and regulations throughout the testing process ensures compliance and minimizes the risk of errors or safety hazards. By understanding and addressing the challenges associated with radiation damper testing, building owners, facility managers, and fire safety professionals can ensure the continued safety and protection of building occupants in the event of a fire. Remember, compliance with NFPA 90.1-7.2 is not just a regulatory requirement, it is a critical component of a comprehensive fire safety plan. The importance of radiation dampers and fire protection systems cannot be overstated. These devices play a crucial role in preventing the spread of fire and smoke through ductwork, thereby protecting building occupants and minimizing property damage. Understanding the principles behind radiation damper operation is essential for effective testing and maintenance. Radiation dampers are designed to automatically close in the event of a fire, effectively sealing off the ductwork and preventing the passage of flames and smoke. The fusible link, a key component of the damper, is designed to melt at a specific temperature, triggering the closing mechanism. Regular testing ensures that the fusible link is in good working order and that the damper closes properly when exposed to heat. A thorough understanding of the different types of radiation dampers is also important. Some dampers are designed for vertical installation, while others are designed for horizontal installation. The installation orientation can affect the damper's performance, so it is crucial to select the appropriate damper for the specific application. The materials used in the construction of radiation dampers can also vary. Some dampers are made of steel, while others are made of aluminum or other materials. The choice of materials can affect the damper's fire resistance and durability. When selecting a radiation damper, it is important to consider the fire rating. The fire rating indicates the amount of time that the damper can withstand exposure to fire without failing. The fire rating should be appropriate for the specific application and should comply with local building codes. Proper installation of radiation dampers is essential for their effective operation. The dampers should be installed according to the manufacturer's instructions and should be properly sealed to prevent leakage of smoke and fire. Regular inspection and maintenance of radiation dampers are also crucial. Dampers should be inspected periodically to ensure that they are in good working order and that the fusible link is intact. Any damaged or malfunctioning damper should be repaired or replaced promptly. In addition to visual inspections, functional testing of radiation dampers is recommended. Functional testing involves activating the damper to verify that it closes properly. This can be done using a heat gun or other heat source. The testing procedure should be documented and should be performed by qualified personnel. It is important to keep accurate records of all inspections, maintenance, and testing activities. These records can be used to demonstrate compliance with NFPA 90.1-7.2 and other applicable codes and regulations. When troubleshooting radiation damper problems, it is important to follow a systematic approach. Start by visually inspecting the damper for any obvious damage or defects. Then check the fusible link to make sure that it is intact. If the damper is not closing properly, check the closing mechanism for any obstructions or malfunctions. If the problem cannot be resolved, consult with a qualified fire protection professional. Fire safety is a shared responsibility. Building owners, facility managers, and fire safety professionals all have a role to play in ensuring that radiation dampers are properly installed, maintained, and tested. By working together, we can create safer buildings for everyone. The specific requirements for radiation damper testing can vary depending on the jurisdiction and the applicable codes and regulations. It is important to consult with local authorities and qualified fire protection professionals to ensure compliance. In some cases, the AHJ may require more frequent testing or may have specific requirements for the testing procedure. It is also important to stay up to date on the latest changes to NFPA 90.1 and other applicable codes and regulations. These codes are constantly evolving to reflect new technologies and best practices. By staying informed, we can ensure that our fire protection systems are as effective as possible. In conclusion, radiation dampers are an essential component of fire protection systems. Proper installation, maintenance, and testing are crucial for ensuring their effective operation. By following the recommendations outlined in this discussion and by working together, we can create safer buildings for everyone. It is also important to consider the integration of radiation dampers with other fire protection systems such as fire alarms and sprinkler systems. A well-coordinated fire protection system can provide a more comprehensive level of protection in the event of a fire. For example, a fire alarm system can alert building occupants to a fire, while a sprinkler system can suppress the fire and prevent it from spreading. Radiation dampers can then prevent the spread of smoke and fire through the ductwork, further protecting building occupants and minimizing property damage. The design and installation of fire protection systems should be performed by qualified professionals who have expertise in fire safety engineering. These professionals can assess the specific hazards of a building and design a system that is appropriate for the occupancy in the building's construction. It is also important to consider the accessibility of radiation dampers for inspection and maintenance. Dampers should be located in areas that are easily accessible so that they can be inspected and maintained without difficulty. In some cases, it may be necessary to provide access panels or other means of access to the dampers. The cost of radiation dampers and their installation and maintenance can vary depending on the size and complexity of the system. However, the cost of fire protection should not be a primary consideration. The safety of building occupants should always be the top priority. Investing in a well-designed and properly maintained fire protection system is a wise investment that can save lives and protect property. Remember, fire safety is an ongoing process. It requires vigilance, attention to detail, and a commitment to continuous improvement. By working together, we can create a fire-safe environment for everyone. Another aspect to consider is the environmental impact of fire protection systems. Some fire suppression agents can be harmful to the environment. It is important to choose fire protection systems that are environmentally friendly and that minimize the impact on the environment. Sustainable fire protection practices are becoming increasingly important as we strive to create a more sustainable future. These practices include using environmentally friendly fire suppression agents, minimizing water usage, and designing systems that are energy efficient. By adopting sustainable fire protection practices, we can protect both people and the environment. The use of technology is also playing an increasingly important role in fire protection. Advanced fire detection and suppression systems can detect fires early and suppress them quickly, minimizing damage and protecting building occupants. Remote monitoring and control systems can allow fire protection professionals to monitor the performance of fire protection systems remotely and to respond to alarms quickly and efficiently. As technology continues to evolve, we can expect to see even more innovative solutions for fire protection. These solutions will help us to create safer and more sustainable buildings. In addition to the technical aspects of fire protection, it is also important to focus on fire prevention. Fire prevention involves taking steps to reduce the risk of fire in the first place. This can include implementing fire safety programs, educating building occupants about fire safety, and enforcing fire safety regulations. By focusing on fire prevention, we can reduce the number of fires that occur and minimize the damage that they cause. Fire safety is a team effort. It requires the cooperation of building owners, facility managers, fire protection professionals, and building occupants. By working together, we can create a fire-safe environment for everyone. The information provided in this discussion is intended for general guidance only and should not be considered a substitute for professional advice. It is important to consult with qualified professionals to obtain specific advice regarding fire protection and compliance with applicable codes and regulations. The field of fire protection is constantly evolving, and it is important to stay up to date on the latest changes and best practices. By continuing to learn and improve, we can ensure that our fire protection systems are as effective as possible.